solving quadratics using the quadratic formula, but answering in simplest radical form. In this example, the directions say to solve the quadratic equation for the exact value of x. This phrase is very important because even if you're able to identify the a, b, and c values and correctly put them into the quadratic form, you might get an answer that's irrational. That's a number that can't be written as a ratio of two integers, or more simply stated, a number that never ends and never repeats. When that's the case, then that means you do not know the exact value of x. So in order to find an exact value of x, you cannot convert it to a decimal. But what you should do is focus right here on the discriminant. That's the expression underneath the radical sign. So we're going to type just this expression in the calculator this time. And when we press enter, we can take that value of 20 and write it underneath the square root sign instead of all that math. Everything else will remain the same. So we have a 4 here after we simplified. We still have the plus minus sign, but now we have the square root of 20 instead of a whole math sentence. What you're going to do after this is simplify this radical, right? This square root of 20 can be factored into two different numbers, and one of them could be a perfect square, like 4 times 5. And if I have the square root of 4 times the square root of 5, then I can take the square root of 4. And when I do that, it comes out as a 2. So the 4 gets square rooted, but the 5 does not. Now that I have rewritten this sentence, I can attempt to further simplify it. To do that, I'm going to take this numerator, right, this expression here that has two terms, and I'm going to divide them both by the denominator. So I'm sort of thinking of it separately, like 4 divided by 2, and then 2 square roots of 5 divided by 2. Now this is some simple math. We're just reducing this fraction. This one over here is a little bit more complicated because this 2 down here can only do math with this coefficient 2 out here. It cannot do any math with this radical number. But 2 divided by 2 can reduce to 1. And another way of writing 1 square root of 5 is to leave the 1 invisible. Just like this. And this is an exact value of x. So let's recap. In order to find an exact value of x, you need to simplify the discriminant, right? That's the expression underneath the radical sign. In order to do that, you have to compute the math and then rewrite that radicand as a pair of factors, meaning that 1 would need to be a perfect square in order to simplify. Once you have that, you can take the square root of the perfect square and bring it outside of the radical sign to write it as the coefficient, and the other factor will remain underneath. Let's try this one more time. Identify your a, b, and c values. Erase and replace those letters in the quadratic formula. Which is negative b plus or minus b squared minus 4ac all over 2a. Now, instead of computing the whole thing on my calculator, I'm going to compute just the discriminant. So we're going to compute parentheses, negative 6 parentheses squared, subtract 4 parentheses 4 parentheses negative 5. Once I've computed the discriminant, I can rewrite this front value here. Negative 6 and negative 6 is positive 6. The plus or minus sign remains. The denominator can become 8. And then from our calculator, we got the radicand of 116. Now here's where you need to start renaming this 116 as two separate factors, with one being the greatest perfect square you can find. So in order to check that, we're going to type the number 116 and we're going to start dividing by the perfect squares. So maybe we start with something around half of that, so about 50 or 60-ish. So maybe we'll try 49, and that's not an even number, so that's not a factor. Maybe we try 36, and that's not an even number, so that's not a factor. So maybe we try 9, and then we go down from there and we keep guessing our perfect squares. How about 4? Okay, that is a whole number, so 4 is a factor, and so is 29. Now I know 4 is the greatest common factor because 29 is prime, and that cannot be factored any further. So we've got a 4 and we've got a 29. Now the 4 is square rootable. So don't forget that comes out and becomes the coefficient. So 6 plus or minus, all of this will remain, but the radical number 116 will disappear. The 4 will come out as a 2 and the 29 will stay underneath. So technically, we've simplified this, but sometimes these outside numbers here can also be reduced. So we're going to reduce 6 and 2 by finding something, a factor, that can reduce them that can also go into 8. So I can use 2 here, which would give me 3 plus or minus 1, and the 8 would be reduced to 4. And this is the final solution. And that is how you find the exact value of x when you're solving a quadratic equation.